Greetings. In this one, let's discuss whether this matrix has a right inverse. That means, does there exist some x2 such that if we multiply x1 by x2 on the right side, it will equal to the identity? So this question, alright? And note that it's on the right side from x1. So if this x1, we want to find some x2 that we multiply this matrix on the right. The question to this answer is whether rank of the matrix equals to the number of rows. So the rows are linearly independent. We can find the right inverse. So let's see if that applies. For that, what we can do is do some row operations here. I will do only one row operation to figure out the rank. Namely the column space, but that should equal to the row space and so on. So that would be add -2 times the first row to the second. And that would be as following. And here we already see that we have a pivot column, another pivot column. This one is not. And so indeed, there is 2 pivot columns, rank is 2. So rank of this x1 is 2 now, we see, equals to the number of rows. We can find the right inverse in theory. And now let's go into the technicalities of finding the right inverse. So actually, if we have this matrix, it's 2 by 3, 2 rows, 3 columns. We want to find some x2, so this was 2 by 3 and 2 times 3. This means this subindex. We want to find inverse that will be switched in these dimensions, so 3 by 2. So we can multiply it on the right, the dimensions match. This 3 must match with the first dimension for the other one. And actually, the outer dimensions, the 2's on here outside, should give the dimension for the identity that we're looking for. So actually, it will be identity 2 by 2. So we want this times some matrix to equal to identity with 2 rows, 2 columns matrix. And that would be namely exactly this. So let's look for that. We also have to find some more details. So if we have this matrix 1, 0, 4, 2, 3, 0, we multiply by some x2. That's going to look more like this. It's going to be the switch dimensions. So this is 2 by 3. This will be 3 by 2. So it will be the same but vertically oriented. And it should give this. And actually, finding an inverse for this, well, all we'll have to do is pick just this block part. So actually, here we see it in the original. And for that we'll find an inverse. And then we put that inverse up here on this top block, and this bottom row will be zeros, and it works out as follows then. So let's see. I'll find the inverse for this using the usual algorithm. That means put the identity on the right side, keep the block that we chose, the left block, from this matrix, these 2 first columns, right here, unchanged, put the identity here, and perform row operations until this becomes the identity and this becomes actually the inverse, once this becomes the identity. So subtract the first row from the second minus 2 times. So you have firstly this, and then in the next step we already get to the inverse. So here it's identity on the left side, and we just have to divide by 3 the second row. So here we have it. Now this thing on the right is the inverse. It will be the block that will replace this right here. So 1, 0, -2/3, 1/3.